Hello everyone, my name is Ali Reza Mahimpavar, and today I'm gonna talk about my project for uh, ISC class, ISC 244 AI tools under Dr. Shilpa Gupta. I'm final year master's students in the field of AI, artificial intelligence, and my topic for today is algorithms in the handwriting recognition. So to give you an idea, let's first talk how I picked this topic and why I picked this topic. As you know, in today's world, the usage of the uh, ML algorithms and ML products and machine learning products and AI products is increasing. And one of the well-known products and technologies and the companies and are using these days are handwritten recognition tools. So handwriting recognition is a crucial problem faced by the tech companies today. The increased usage of the ML algorithms and AI highlights the needs of an accurate handwriting recognition. And handwriting recognition issues impact various sectors, including digital signatures, document processing, and mail sortings. So, but why this issue is so important these days? So, to talk about this, it says that the time and efficiency is the first key for the importance of this problem. Improved handwriting recognition saves times and enhance efficiency in the tasks like mail sorting, check processing, document filing, as I told, and converting handwriting text to the electronics form enables the optimal storage and organization of the documents, contracts, and personal records. So optimal storage is another key factor that makes this problem so important. Enhanced experience and industry benefits as are another key factors for the importance of this problem. So as you know, addressing the handwriting recognition challenges enhance customer experience and streamless operations in the industries like postal banking and document processing industries. And the advancement in these technologies benefits the industries and benefits the companies. So for that, the scientists for the past couple of years, they have come up with the methods and algorithms to solve the problems and issues related to the handwriting recognitions. So the three main algorithms that they use are least squared support vector machines, LS-SVM, and the two major ones that they use these days is a recurrent neural network or RNN and convolutional neural network or CNN. So I'm gonna explain how these algorithms works and what are these algorithms, and I'm gonna talk about how my project works. So to talk about it first, let's talk about the CNN and how CNN works. The CNN is the deep learning algorithm for image processing and pattern recognition. It uses convolutional layers, pooling layers, and fully connected layers. And convolutional layers extract the features like edges and shapes and textures. Pooling layers, downsampling features map uh, with retaining important information. Fully connected layers perform classification based on extracted features, and CNN can handle translation invariance through the patterns sharing. And training involves forwarding, backwarding, and optimizational algorithms. And CNN excel in the capturing the spatial relations for tasks like image classification and object detection. And the pre-trained CNN models are VGG, ResNet, and Inceptions. Offer transfer learning capabilities. But how are we going to use this on the handwriting recognition? So by utilizing the CNN's ability to capture visual patterns and spatial relationship in the handwriting images. We designed the CNN architecture specifically to tailor for a handwriting recognition task, and we trained the CNN model on labeled handwriting datasets, which is the USPS datasets, to learn and extract relevant features. And we leverage convolutional layers and pooling layers to capture low-level features and complex patterns in the handwriting images. And finally, we apply fully connected layers to capture dependencies along the extracted features for accurate recognition. So the second method and second algorithm that we are going to talk about it is RNN. But what is RNN? RNN is a neural network for sequential data processing, and it maintains an internal memory in the capturing the sequential information. RNN includes the input layer, hidden layer, and output layer, and it handles variable length input and captures temporal dependencies. LS-SVM is popular RNN cell for handling long-term dependencies. And RNN is used in tasks like speech recognition and handwriting recognition, and training also involved backdropping, backpropagation, forward propagation, and gradient optimization. RNN generates output sequence based on learned patterns, and it leverages sequential contexts and memory for improved accuracy. So, but how are we going to use the RNN or our data set? So we exploit RNN sequential processing capability to capture temporal dependencies in handwriting, develop RNN architecture for sequential handwriting data, and we train the model on labeled data sets to learn and recognize the pattern. We utilize the long short-term memory, or LSTM, to handle long-term dependencies, and we leverages the hidden states of the RNN to capture context and ensure the accurate recognition. And finally, we are talking about the LS-SVM and how we are going to use the LS-SVM in the handwriting recognition. So LS-SVM is the subset of the support vector machine, and it's a modified version of the SVM for handwriting recognition tasks. It processes and normalizes the handwriting data to ensure the compatibility with the LS-SVM algorithm, and perform model to selection to determine the optimal hopper parameter, such as the kernel function and regularization parameter. And we train the LS-SVM model on the labeled dataset to learn the mapping from the input to the output labels. And finally, we utilize LS-SVM's capabilities in handling high-dimensional data and providing good generalization for the accurate recognitions. So what will happen if we combine these models, and how are we gonna do that? So by combination of the RNN, CNN, and LS-SVM methods, we wanted to leverage their respective strengths. We extract the features from the handwriting images using CNN and incorporate them with the feature set. We utilize RNN to capture sequential dependencies in stroke data and include the extracted feature. And finally, we train an LS-SVM model and combined feature set to achieve improved recognition accuracy, investigate the synergy between the CNN, RNN, and LS-SVM for enhanced performance in handwriting recognition tasks. And now let's go talk about demo, and we see how the demo works. So Before I start the demo, the data set that we used in this project is a USPS data set. And my main goal was to perform each of these algorithms on this data set to see how are we getting the accuracy on this data set, specific data sets, and what are the chances that uh, to improve the algorithms if we combine the methods together to come up with a hybrid model to see if that is going to change anything in terms of the accuracy on training sets or test sets. So at the beginning, let's look at the code. So we imported the required libraries for the code, and we loaded the data sets, and we did the normalization and pre-processing and reshaping the target arrays for it. And we printed out the shapes of the array to see what are we doing and what do we have. So these are the, you see that XTR, YTR, X train, Y train, X test, Y test, and how the sample works, and the sample data and the target data. Yes. So this is the beginning. This is the first model that we use for the RNN method. So we split the data into the training and validation sets at first. And then we reshape the data for the RNN models. As we see, we define the X-train, X-val, and X-test. And then we defined our model, and we compiled the model, and we trained the model, and then we got the evaluation on the validation set and test sets. And then we performed a plotting to plot the results for the accuracy of this RNN model on these specific data sets. And as we see, the validation accuracy that we got on the RNN is 56%, and the test accuracy is 54%, 55%, which shows in this diagram as we see. Which sees that RNN gives us the not good results in terms of the accuracy on this specific USPS data set. So we moved forward to see how others algorithms works, So here is the CNN model, and we reshaped the data for CNN model. We defined the model, we split the data for the model, and we compiled the CNN model, trained the model, and then we evaluated the test. We evaluated the model on test sets and validation set to see the results that we want to get, and plotting the results. And we see that the validation accuracy increased up to 80%, and the test accuracy increased up to 72%. And as we showed over here, finally, we started working on the last algorithms that we had, which is the LS-SVM. So we did the same process, reshaping, splitting into the train and test data sets, and training the model, predicting the data to calculate the accuracy on the test and validation to see how the things is going. And we see that the validation accuracy increases on both test and validation sets. And for the validation set, it's 94%, and for the test sets, it's about 90%. So at the end, we said that, okay, LS-SVM is performing the highest results and highest accuracy on these data sets. Let's give it a shot to see if we can combine the models and how it is gonna change the accuracy and on test sets and validation set. So we did the same process again, And here we define the CNN models and extract the CNN features for training and validation set. And then we train the LS-SVM model using the CNN features that we extracted. And then we calculated the accuracy and predicted the labels for the validation and test sets. So, and then we did the plotting. So the CNN and LS-SVM combination gave us about 92% accuracy on validation set and 89% on a test set as an accuracy. So it shows us like the combination of the LS-SVM and CNN did not really improve the accuracy and on tests and validation sets that we had for the LS-SVM. And yeah, and finally, for the final things, we did like the combination of the LS-SVM, CNN, and RNN to see how the results changed. So we reshaped the data for the CNN model, and we did it for the RNN model. And then for the as a step one, we defined the CNN models, and for this step two, we added the RNN model, and then we added the regularization for the LSTM layers. And we performed the LS-SVM model on it, and we combined the features trained and on the step 4, we predicted and evaluated the results to see the score on the evaluation, on the validation set and test sets on these data sets with the combined method. And you see that the validation set accuracy and test accuracy are at the highest, 93% for the validation set accuracy and 89% for the test set accuracy. But the result didn't really change compared to the LS-SVM individually. By showing and plotting all the validation accuracy, we see that the highest accuracy is like comes to the combination of the CNN, RNN, and LS-SVM. And after that, LS-SVM individually has the highest accuracy, but the differences are not that much. It's 93.2, and this is 93%. And then with a little bit difference, it's just like combination of the CNN and LS-SVM. And same thing happens for the test set accuracy as well. The highest goes for the LS-SVM, RNN, CNN, and then LS-SVM is the second, and then the combination of the CNN and SVM is the third with a slightly difference. So we see that this combination and coming up with the hybrid model thing did not really improve the score and accuracy. And on this specific data set, LS-SVM can perform and give us the best result out of all these algorithms, and there's no need of the hybrid model. Thank you.